So we have a meter long rod. So we have a 1 meter long rod. And it has a mass density that varies linearly from lambda a 1 kg at one end, x is equal to 0. So this is point A and this is point B. And here the mass is 1 kg, sorry, density is 1 kg per meter cube. And at this end, we have 3 kg per meter cube. Calculate the center of mass. Okay, so for us to understand, for us to discuss this better, I have a graph. So this is the origin, the density, right? Density versus height graph. That's what I have over here. So let me just do one more thing. So let me place it over here. Okay. And then our 0, 0 will be over here. Yeah. Now this is 1, this is 2, and this is 3 in terms of density. Okay. This is kg per meter. And height is meter. So this is say at a length of 1. So what this is telling is, actually you guys should be telling how the graph looks like. If I have to plot a density versus height graph for this, how will it look like? Your first clue is it being linear. So it is a straight line. Now, straight line, how it is? Is it increasing this way or this way? Is this increasing or is this increasing? So this is increasing, right? This is an increasing example. So is this it? No, this is wrong. What's wrong about this? Because the density starts with 1 and moves on to this. And this as an equation can be represented as, correct, the y mx plus c. Here the slope is for 1 unit, there is 2 increase, so 2x, and the y-intercept is 1, 2x plus 1. You should be able to write this. Okay guys, so let me do the working. The very first thing is the density function. We call this as density function. So lambda with respect to x can be written as 2x plus 1. Why? I already explained. Okay, next we can talk about total mass. How do you figure out the total mass? Yes, we need to use integration. So we'll integrate density across the length from 0 to 1. Okay, so this again, writing all of this and making sense out of it is very important. So this is about adding. This is your density and this is length. Density into length will give us the mass, because unit of density is kg per meter and length is meter, and we have the answer. Okay, so we'll get the mass basically. So this will be m is equal to integration from 0 to 1, 2x plus 1 dx. So this is equal to x square plus x 0 to 1, and this is nothing but 2 kg. Okay guys, so that is your mass. Then we can figure out the center of mass. Center of mass along the y-axis, we are considering it to be a, this structure. So along the y-axis it's 0, right? Only thing that we have to figure out is the x-axis. So 1 by m integration from 0 to 1 x lambda x dx. I hope you guys remember this formula. So this is actually basically dm, and this is xi to xf. Substituting dm, it is a function of, right, x over here, the length. And so if you substitute this, then we have this formula, and then the limit also. So this is 1 by 2, 0 to 1 x, and this is 2x plus 1 dx. And yeah, it's just a matter of x square plus x cube by 3, 2x cube by 3, and this is x square by 2, 0 to 1. So 1 by 2, 2 by 3 plus 1 by 2. So LCM here is 6 and 12 in the denominator. This is 4 plus 7 by 12. Okay, so that's that. So your final answer, you guys can figure it out. Just a matter of writing it, that is. Okay, so here the important thing is that you should know this. And how do you know this? This you have to go to math, lines and angles. That's one of the last chapters that you guys have to know. 11th or 12th, it comes somewhere, guys. I forgot where exactly, but yeah.